Hello, hi, and assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ain Atikah binti Kizli.
Hi, my name is Nurul Najwa Bitakiruddin.
Hi, assalamualaikum. My name is Nur binti Ana, and we are from class AS1202A.
Okay, so first, let's take a look about the content in this video presentation. Okay, first we have introduction to graph of polynomial function. Second, we have steps to solve polynomial function. Third, we have question for graph polynomial function. Fourth, we have procedure to solve optimization, maximum or minimum problems. And the last one, we have the equations for optimization, maximum or minimum. First, before we jump up to the question of graph polynomial function, this is the introduction. So, function of graph polynomial is a function which involves only non-negative integer powers or only positive integer exponents of a variable. In the table below is the most common types of polynomial function. Okay, first, we have degree 0, the name is constant. Second, we have degree 1, the name is linear. Third, we have degree 2, the name is quadratic. Last but not least, we have degree 3, the name is cubic. And the last one, we have degree 4, which is quartic. Okay, next is steps to draw graph of polynomial function. Okay, there are 4 steps, which is first one, we must have x-intercept. Second, we must have y-intercept. Third, we must have maximum or minimum point. And the last one, we must have inflection point. Okay, here is the first question, which is graph of polynomial function. This question is come out from the past equation, which is March 2016, question 3a. So the question is, given a function fx equal to 2x cubic plus 3x squared minus 12x minus 2. So the question is, find the x-intercept and y-intercept for f. Okay, to find y-intercept, we must substitute x equal to 0 into the equation. So after we substitute it, we will get the coordinate of y-intercept is 0, negative 2. While to find x-intercept, we must substitute y equal to 0 into the equation. So we will get x-intercept is equal to 1.910, negative 3.250, and negative 0.160. So here is the second question, which is find intervals where f is increasing and decreasing, hence determine the relative extremum of f if any. So the first step is we must find the first differentiation, which is f prime x. So we get 6x squared plus 6x minus 12. After that, we must assume it equal to 0, so that we will get the value of x is equal to 1 and equal to negative 2. So after we get these values of x, we must substitute it into the equation. So after we substitute it, we will get the coordinate is 1, negative 9, and also negative 2, 18. Okay, the next step is we must do the table below. So the first step is we must write down the intervals. So the intervals is negative infinity, negative 2, negative 2, 1, and 1 infinity. So the next step is we must write down the test value. So the test value is negative 3, 0, and 2. So after that, we must write down the sign of f from x, which is come out from the test value. So the sign we will get is positive, negative, and positive. So after we get this sign, we can determine the slope, which is for the positive sign, the slope is increasing, while for the negative sign, the slope is decreasing. So on the side we have the maximum point and the minimum point. So the maximum point is negative 2, 18, and the minimum point is 1, negative 9. So here is the next question, which is question number 3. The question is, find the intervals where is concave up and concave down. Hence, determine the inflection point of f if any. So for the first step, we must do the second differentiation, which is f double prime x. So we will get 12x plus 6. After we get f double prime x, we must assume it equal to 0. After we assume equal to 0, we will get x equal to 1 over 2. Okay, the next step is we must complete the table below. So in the table, for the first step, we must write down the intervals. So the interval is negative infinity, negative 1 over 2, and negative 1 over 2, infinity. Next is the test value. We also must write the test value. So the test value is negative 2 and 2. After we jot down the test value, we must write the sign of f double prime x. So the sign is negative and positive. So after we get the sign, we will get the image of concavity. So for the negative sign, we will get concave down, while for the positive sign, we will get concave up. So on the next slide, we can write concave down equal to negative infinity, negative 1 over 2, while concave up is negative 1 over 2, infinity. Okay, on the below, we will get the inflection point. So to get inflection point, we must substitute -1/2 into the equation. So we will get the coordinate of inflection point is -1/2, 9/2. Okay, so here is the last question for the graph of polynomial function questions. So the question is sketch of graph of f. So in the graph there have maximum point, minimum point, inflection point, x-intercept, and also y-intercept. So this graph was followed the step that I said in the previous slide. Okay, so the next slide is the procedure to solve maximum and minimum problems. So basically there have two parts. So here is the part A, which is set up the formula to be differentiate. So as we can see in this slide, there have 4 steps that we must follow to solve the maximum and minimum problems. Next is the second part to solve maximum and minimum problems, which is application of derivative. So here we have 5 steps that we must follow to solve the question of maximum and minimum problem. Here is the next question for the last topic, which is optimization, maximum or minimum problems. Basically, this question is came up from the past year question, which is December 2018, question number 3C. So the question is, figure 1 shows a closed small cylinder can with radius RCM and height HCM is placed on large cylinder. The radius of large cylinder is 2 RCM and height 2 HCM. So the question is, if the surface area of the both cylinders are 315 pi cm squared, express h into the terms of r. So the first step to solve this question is we must find the surface area of both cylinders. So basically, as we can see on the figure side, there have 2 sides of cylinder, which is small cylinder and a big cylinder. So for the formula of small cylinder is pi r squared plus 2 pi r h, while for the formula of big cylinder is pi 2r squared plus pi 2r squared minus pi r squared plus 2 pi 2r 2h. So why we put the bracket into the into 2r and 2h, because we can see on the question we must express h into the terms of r. So the final formula for big cylinder is 7 pi r squared plus 8 pi r h. The next step to solve the question number 1 is total up the area. So on the question, the total area is equal to 315 pi. So we can write as 315 pi equal the formula of both cylinders, which is pi r squared plus 2 pi r h plus 7 pi r squared plus 8 pi r h. After we cut the formula, we will get 10 r h equal to 315 minus 8 r squared. So because the question want we to express h into the terms of r, so we will write as h equal to 315 minus 8 r squared over 10 r. Okay, so for the next question is question number 2, shows that volume of both cylinder are given by V equal to 315 pi r minus 7.2 pi r cubic. So for the first step is we must find the volume of each cylinder, as we know that the size of there have 2 sides of cylinder. So after we total up the volume, we will write as V equal to 9 pi r squared h. So the next step is we must substitute h into the V. So the original formula is V equal to 9 pi r squared h. So the h here is we must substitute the h from the previous question, which is 315 minus 8r squared over 10r. So we can write as V equal to 9 pi r squared times 315 minus 8r squared over 10r. So after we cut the formula, we will get V equal to 315 pi r minus 7 pi r cubic. So it is shown. Here is the last question for this video presentation. The question is determine R in centimeter so that the volume is a maximum, hence find the maximum volume of both cylinder. Okay, to solve this problem, step 1 is we must find the derivative of R. So from V equal to 315 pi R minus 7.2 pi R cubic, after we differentiate it, we write dv over dr equal to 315 pi minus 21.6 pi r squared. Okay, after we get this, we must find the value of r in step 2. So we must assume dv over dr equal to 0. After we assume equal to 0, we will get r equal to 3.82. Okay, after we get the value of r, we must do the second derivative test to check whether the value is the maximum or minimum. So after we do the second derivative test, we get the negative value, so that is proof the value is maximum. So after we get this, we just substitute r that we get from the step number 2 into the equation. So we can write as a v maximum equal to 315 pi times 3.82 minus 7.2 pi times 3.82 cubic. So we will get the final answer is 2519.40 cm cubic. So I think that's all from us. Thank you.